So just going through the example that we did in the lesson, the easy version. So we know that we start with 10 volts and we've got different loops, so 3 in this case. If we want to find the current, the first thing to do I would suggest is calculate the resistance in each of the loops. So 3 plus 4 equals 7, and 5 plus 6, because they're in series, they add up, so that equals 11, and then 7 of course by itself, so that's 7. So there's lots of different ways of tackling this, but I would generally find the total resistance in order to find I1. So to find the total resistance, we've got 7, we've got 11, and we've got 7 again. They're in parallel with each other, so we need to remember that to find the resistance in parallel, it's 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So that then, if you put that into a calculator, comes to 29 over 77. However, we always need to remember to flip it over, because it's 1 over RT equals that. So RT over 1, the inverse, is 77 over 29. So that gives us 2.7 ohms. So our total resistance is 2.7 ohms. If we were then to draw that, we've got our 10 volts here, so now the total resistance is 2.7, and we're trying to find I1. So in order to do that, we know that we've got 10 as our total voltage, and we've just calculated our 2.7, so our I1 value is 3.7 amps. It's important to keep that somewhere handy, so I've just rewritten that again just here. The next step might be to find I2. Now the current flowing through for I2 is going through these two resistors, so we know that the total there is 7. The voltage in that same loop is still 10, so we've got 10 over 7, voltage 10, resistance, total resistance in that loop is 7, so that gives us 1.4 amps. We've now got two currents, we've got I1 and I2, so we know that at a junction, so this junction just here, we've got I1 coming in, I2 and I3 are leaving it. So I2 plus I3 equal I1. So to find I3, we have to take away 3.7 and 1.4, our two values from I1 and our new one from I2, so that gives us I3 equaling 2.3 amps. The next stage might be to find I4, so this time I'm taking the outside loop, so this time the voltage is still 10 because we've only got one cell in the circuit, and the resistance in that loop is 7. So to find the current flowing through that resistor, it's 1.4 amps. We're now in a situation from the previous bit where we know I3, we now know I4, so we can calculate I5. Same rule as before, except this time I3 is coming in, leaving is I5 and I4. So I3 minus I4 gives us I5, which is 2.3 minus 1.4, so that's 0.9 amps. So what's useful about doing these circuits is you can just see if your answer is likely to be right. So we can again do the same calculation, but this time focusing on this loop, so that encompasses I5 going through those two resistors. We know the voltage is still 10 in that loop. Now the resistances, well, they're in series with each other, so they add up to 11. So it's voltage 10 over 11, which then gives us 0.9 amps, which is what we got down here for I5 as well. So big tick. Let me know if you've done the harder one, and then I'll happily make another video to go through the answer to this one.